thanks everyone for coming, and it's been great pleasure to basically share the latest sort of progress on our layer side. As the title mentioned, right? So basically, we will show like how we use restaking to secure rollups. And as we all know, right, these days, if we want to set up the rollup, right, it's quite straightforward to basically leverage some of the rollup providers like us to basically quickly launch these rollups, and it's as simple as sort of deploy smart contracts. And these days, right? And so basically, if we look at the market, we already have Optimism, Arbitrum, Polygon, and zk-Sync. And beyond that, we also have a bunch of these application rollups. And we believe that by the end of this year, right, probably in the market, we can have over 1,000 rollups in general. And for most of the rollup stacks, right, as you can see, either for Optimism, it's OP stack, and Arbitrum, it's Orbit. And Polygon CDK is sort of like another zk rollup stack. And right now, we also have a zk-Sync, the zk stack. With all the sort of rollup stacks, right now we can quickly launch these rollups, as I just mentioned, right? As simple as deploying smart contracts. So, but for most of the rollup stacks, or even for the existing either general purpose rollup or application rollup, right? We have so many of them, but at the same time, as I show you, there are a lot of issues and problems for these rollups. One of the problems that basically it's a single sequencer. No matter it's Optimism, Arbitrum, or Polygon zk EVM, and also Coinbase base, it's only like sort of one sequencer. When we sort of send transactions and only one sequencer on the server process all the transaction and generate blocks. So in that case, as you can see, right, there's a single point failure. And beyond that, we all know that if it's a single sequencer, sometimes the server can redo the censorship. And at the same time, since it's just one node, if it's down, then basically we couldn't process any transaction for the rollup. So in that case, right, we probably need a decentralized set of operators or validators to do the extra verification for the sequencer to ensure that, okay, even the sequencer is down or sometimes it doesn't want to include some transactions, we can still have sort of the backup to process the transaction. And beyond that, if the sequencer is behaving maliciously, right, we can have a decentralized set of validators to do this verification. So that's why, today I mentioned that we can leverage some new technologies like this restaking technology proposed by EigenLayer to provide this economic security to secure most of these rollups by running a decentralized verification network or decentralized sequencing network to do this extra verification for all the existing rollups. And that's something we are proposing called restate rollup. Basically, we leverage the restaking and the share security and to secure these rollups by providing this decentralized verification or decentralized sequencing. And as you can see, right, restate rollup is a new concept we proposed together with EigenLayer since last year. We've been working on this concept and the product for over 2 years. And so what's sort of restate rollup? Before we know what's restate rollup, we should know what's not restate rollup. So it's not a new rollup stack. So basically, it's completely compatible or agnostic to the existing rollup stacks. For example, we still provide OP stack, Arbitrum, Orbit, Polygon CDK, and also zk-Sync. On top of that, we can provide these extra advanced features with the restate rollup. And beyond that, it's definitely not L2. Some of the friends and also community members ask us, when we launch our restate rollup L2, but actually it's not a dedicated L2. It's a bunch of advanced features provided by the restate rollup. And the third point that it's not like extra sort of proof for it. Because if you are using optimistic rollup, right, your security is guaranteed by the fraud proof. If you're using zk proof, then you have a zk rollup, the security is guaranteed from the zk proof. So what's Restaking Rollup? As you can see, right? For Restaking Rollup, it's a bunch of features on top of the existing Rollup stack. So what it can provide as it's basically compatible with all the existing Rollup stacks. And on top of that, we can also have a decentralized network to secure this either called single sequencer, or sometimes on top of a decentralized verification network, we can also have this sort of like extra property on top of it. For example, this fast finality property, and which can be leveraged by the exchanges and also the bridges to achieve this fast finality. As you can see, right, so far we've been developing this Restaking Rollup for years, and we already provide these services on top of all the existing Rollup stacks. For example, OP Stack, Arbitrum Orbit, Polygon CDK, and also ZK Sync. In general, as the first set of features, advanced features by the Restaking Rollup we provide, first one is Vital. It's a decentralized verification network. The second one is the fast finality MARC. It's on top of the Vital. And the last one is decentralized sequencing. So for Vital, as I mentioned, right, for the current rollup, we basically have to trust the single sequencer, either trust them to process all the transaction on the timely like manner, or sometimes like we have to trust the single sequencer without any proof. For example, the current like OP stack or OP chains, they don't really have the fraud proof yet. And beyond that, for some big projects like Optimism, Midnight, Arbitrum, or even Coinbase Base, we know they are like sort of big projects. They have very good backers, so they don't behave maliciously. But for some new project, right, some app chains or gaming, social, like rollups, when they launch this kind of rollup, probably we don't really want to trust them. It's a single sequencer, even they have the fraud proof or ZK proof, but we don't know them. But right now, what we provide as part of the Restaking Rollup, we can have a decentralized network to do the extra verification for these blocks generated by the single sequencer. So in that case, you don't really need to trust the single sequencer, but instead, you can leverage this decentralized network like powered by this eigenlayer AVS created by us to really have this decentralized verification result. On top of it, as I mentioned, right, once we have the decentralized verification network, we can do a lot of interesting stuff. The first one is the fast finality. Since we have this verification network, we don't really blindly trust this sequencer, right? But since the performance of the decentralized verification network is very fast, so we can still get this RPC request, like sort of response within a few seconds via this network. So in that case, for bridges, exchanges, and also some DeFi protocols, instead of trusting this single sequencer blindly, we can just leverage this MARC to basically do the fast processing for the transfer from one chain to another chain. And beyond that, as you can see, right, one example I just mentioned is mainly for the bridging services. Because right now, if we just trust a single sequencer, right, without doing the extra verification, sometimes for the optimistic rollup, it's a 7-day challenge period. For the ZK rollup, it typically takes a few hours to generate ZK proof. So in that case, for a lot of bridges, they want like faster finality. For example, they want like do the transfer within a few seconds. In that case, either they blindly trust a sequencer, or they can leverage the existing network MARC. On top of that, right, you can definitely balance like sort of the security guarantee and also the finality you want to have. You want to have faster finality, you can enjoy the MARC network with some economic guarantee. And if you really want to have the best security guarantee, the MARC network can also generate the ZK proof for different blocks. So in that case, even takes longer, but definitely the security guarantee is better with this mathematics like analysis. Beyond that, we also provide another feature required by a lot of DeFi protocols who want to run the rollups. It's called Squad. It's basically for decentralized sequencing. Like one way, as I mentioned, right, either we do this decentralized verification network for single sequencer, or we can definitely run a decentralized set of nodes to become these sequencers. So in that case, by default, we have like different sequencers, so we can avoid the single point failure. At the same time, as you can see, right, we can definitely have a better decentralization and a security guarantee for the entire like rollup network. Of course, we are building on top of this eigenlayer for this Restake rollup. And so later on, either you can delegate your Restaked ETH to secure this network, or you can also stake our token to secure this network. If we go deep into like sort of the MAC system, right, as I just mentioned, there are multiple ways to achieve this decentralized verification and fast finality. One way that we say this pessimistic mode, basically all these operators or nodes or validators in the network, they just run full nodes, and basically they do all the transaction execution again. So in that case, as you can see, right, easily we can support as many like sort of rollups as possible without any changes because it's full node. But you know, right, in this mode, it's very heavy. So you have to store all the data and do all the calculation and execution of the transactions. And alternatively, we also have a new mode called optimistic mode. So instead of you passively re-execute all the transactions and generate MPT result, right? So you can basically run some stateless client created by us. For example, for OP Stack, we rewrote everything about this stateless client, so you can just run a very like sort of small piece of software to recalculate the MPT tree. And in that case, you can quickly generate like sort of the results for all the rollups, I mean, from the sequencer. And after that, if there's something wrong, we can leverage a process called bisection protocol from this fraud proof. So in that case, as you can see, right, you can, all the nodes, they don't need to generate proof for every block. They can generate proof and do the bisection challenge protocol once there's something wrong. And on top of that, all right, as I mentioned, apart from you do the fraud proof, we can also use ZK proof. Like basically, once we find something wrong, right, we can generate ZK proof to avoid this bisection protocol. This one-step proof, even it takes some time and the cost a little bit high, but we can do fully like sort of on-chain verification for these ZK proofs. And beyond that, the last like sort of mode is the validity mode. The idea that, as I just mentioned, right, either optimistically we believe all the blocks or transactions processed by the sequencer, it should be fine. If something wrong, we generate proof. But in this validity mode, we always generate the ZK proof. So it's more costly, but at the same time, for some crucial protocol infrastructure, they want to see your ZK proof for every block or every few blocks. So in that case, we can always generate the ZK proof and do the on-chain verification. Yeah, so that's all about the Restake rollup. I think after this quick keynote, I want you to know, like, so for the existing rollups, we have all these centralization problems for the rollup, especially a single sequencer. And by leveraging restaking, and we can basically run these Restake rollup features to do this decentralized verification network and to further secure the sequencer and the rollup. And that's all the new features we are providing at All-Ear. If you would like to check out all the new products and like sort of networks, feel free to contact us via this link. Yeah, thank you.